My name is Kyung Lee, and I have a HCI background, like the previous speaker, Ha Iju. So I'm really excited to be here at this workshop because I've been admiring your work, this community work that tries to formalize different fairness, notions of fairness. The work that I will present today offers a complementary angle and argue that we should consider both fairness in distributed outcomes from the algorithm, but also procedural justice in the way we design and give control to the end user who is using and who are affected by these algorithms. Before I start the talk, I'd like to acknowledge that the work that I will present today was only possible thanks to the hard work that our interdisciplinary team has done over the past 3 years. So I actually started my research career as a human-computer interaction focusing on robots. So I've been looking at how people can interact with a robot that delivers good in the office, or being a helper for the people living independently in their home. But when Uber and Lyft was first introduced to Pittsburgh in 2014, I realized that there are different kinds of robots emerging in the world. So there are robots in the Uber app. Yes, they don't have bodies like the physical robot that you saw in the previous slide, but they're making decisions autonomously on their own. So it was in a way robots. But they are not our colleague or helper that I'm used to frame in my work. Now they are influencing, making decisions that give jobs to driver and influence how much they earn. So I started calling this emergence of algorithmic robots or robotic boss as algorithmic management. And with this community, I don't have to emphasize that this algorithmic management is integrating into workplaces and cities steadily, but increasingly. So these AIs are not just deciding what we see online. They manage worker routines, tasks, incentives, and who is offered jobs or small loan businesses, some small business loans. And this AI is also being applied to criminal justice systems and government programs. And from human perspective, this context of AI differs from traditional AI applications in 2 ways. So first, these managerial or governance contexts involve new type of users. If you get a Netflix recommendation as a user, if you don't like it, you can just ignore it. But if you are workers and get a work assignment from the algorithm, it's more difficult to say no. So this means that we need to consider both those who are affected by AI decisions, like the workers getting the job from the algorithm, and the management, those who use the AI to make decisions. And we don't yet know enough and consider how people who are affected by algorithm feel about this algorithmic management. And emerging evidence suggests that actually they are not feeling great about it. So I conducted a study in which I told people that they were selected for an interview, and then said this decision was made by a human manager versus the algorithm. And then findings suggest that people were actually thought that having their resume screened by algorithm was less fair, less trustworthy, and it provoked more negative emotions compared to human decision makers. The majority of people mentioned that they distrust the algorithm because they cannot sufficiently analyze factors they believe in place of human, like considering personality or work cultures. So they thought that even though the algorithm can be objective and don't have human biases, they were concerned that the accuracy of the algorithm will not be enough to be used in this context.
Can you clarify, were these people who would have applied for a job, or was this a pool of people like in LinkedIn where the algorithm or the human was going and looking even though nobody had applied?
So I want to clarify that I wanted to compare source bias I wanted to know whether the knowledge of the decision maker, whether it's algorithm or human in itself, can influence how they view the outcome. So this was done experimentally online. So this was not done in LinkedIn. So it was like MTurkers
No, but you're asking people how they would feel about it.
Yeah.
And so were they imagining that they were in the situation where they had actively applied for a job?
Yeah.
Okay, thank you.
Online, yes. So they applied, they submitted their resumes and online, and then they get notification.
Specific job.
Yeah.
Thank you.
And for them, it was a real situation. They were not aware that they are participating in the experiment, right?
They knew that they were participating in the experiment. As a part of human subject, we usually need to inform that they are doing a study, but we didn't tell them like what we are manipulating. So we told them that you're gonna be in situation and tell us how you feel.
So they knew that there was no job waiting at the end of it.
No, yeah, they didn't know. Yeah,
didn't
so
know
it's a,
They knew that or they didn't know that?
they knew that there is no job. So it's a hypothetical, and then, so this is a first step toward understanding the perceptions algorithm, but obviously we need a lot more work, yeah. But one thing that was really interesting to me was that, yes, it is about concerns of the accuracy, but also the fact that people can be judged or evaluated by the algorithm in itself can be dehumanizing. For example, one participant said that I will feel like a machine being chosen by a machine. So this shows that it is really important for us to understand like how we can make these people who will be affected by the algorithm feel that they are still respected in the workplace. The second characteristics of algorithmic management is that it often mediates multiple stakeholders' benefits and costs from using the service. So as Hai mentioned, for example, on-demand work platform like Uber uses algorithm to assign tasks which affect their customer, their workers, and also the company's own profit. And there have been emerging public concern, fears, and some real-world evidences that suggest that these governing AI can be used as a mechanism of control by the management and unfairly prioritizes a small set of stakeholders' benefits at the cost of the rest of the stakeholders. So sometimes this is done intentionally and purposefully. Like for example, the objective of the Facebook's curation algorithm is to maximize the profits of the company and satisfy the ads provider, probably at the cost of the healthy media consumptions in our society. But many times it is also done unintentionally because those who build this algorithm often do not identify these multiple stakeholders upfront. And more importantly, they lack quantifiable metrics that define utilities and values of different stakeholders. So the work that I will present today seeks to flip this dynamic and ask, how can we empower people to design algorithmic governance for their own community? And how can we achieve fairer and more trustworthy decisions than human decisions from the perspective of people who are affected by these decisions? So the work that I'll present today takes the first step toward to answer these questions. I'll first explain how people perceive supposedly fair algorithms and why procedural justice framework matters. And I will then explain my two projects that implement different components of the procedural framework. So the first one, we seek to enable transparency and process control in the framework so that stakeholders can design and build an algorithm for their own community. And I will present a case study with a real nonprofit. And second project, I will briefly mention for a few minutes where we are exploring the effect of transparency and out control. So I explore the human perceptions of task allocation when it's done by the algorithm versus a human. And I want to highlight that we used a fair division algorithm in this study, not generic algorithm or the discriminatory algorithm that we know make biased decisions against certain demographics. So fair division algorithm, I think with this audience, you should probably are very familiar with this concept. But for a lot of HCI audience, it was a very strange or foreign concept. So I will give you a brief overview about it. So it's a subset of AI, computer theory, economics, and mathematics. And they use how much individual value or deserve of available resources as individual utilities and allocate given limited resources to each person while maximizing each person's utility and meeting assumed fairness property. They are proven mathematically to guarantee fairness, which means that they satisfy different properties of fairness in all cases. So for example, the property of envy freeness means that none of the player wants to swap their portion with another because they find all portions are equally valuable. Another property is max min, which maximizes the utility of the person who gets the least among the group. So this kind of algorithms have been used in a variety of domains. They traditionally have allocated computer infrastructure such as network bandwidth, CPU resources, but they are now being applied to more social domains such as policymaking, organizational management, healthcare, education, etc. So I wanted to see how people perceive allocation decision from this fair division algorithm compared to human decision maker. And as an anecdotal study, I was not originally questioning the fairness of the fair division algorithm.
So I mean, there's a mismatch here. We talk about fair divisions with like envy freeness. So each of us has a utility function. I don't want to swap with you.
Yeah.
But if it is about allocating loans, of course, if I don't get a loan,
Yeah.
I'm envy of the person who got the loan.
Yeah.
So I don't see how you marry these two views.
So I want to clarify that this particular study, the algorithm was not machine learning based, and then the resources were limited. So if you're saying that the loan decisions are made by the likelihood that this person will pay off the loan or not, it's a slightly different context. So this is more about wait, am I answering your question?
I don't understand how can you get envy freeness in a situation where you have to allocate a loan or don't allocate a loan. I always be jealous of the person that did get
Yeah,
it.
so for that context, I don't think, yes, envy freeness isn't the right kind of fairness
Envy
notion.
freeness is the criteria
Yeah.
for the fair division.
Yeah.
So how do we define fair division when we allocate loans?
I don't think this particular envy freeness applies to the loans, to answer your questions. It's more on, for example, the allocation of schedule shift, where you have a limited quota and then you have, and then applying like allocating the people's shift according to their preferences or constraint. That's something that this will be applied. Same with the task assignment. I have a firm for a certain task, and you need to divide among the groups. Then maybe envy freeness can apply there. Loan for binary decision, probably not applicable.
I'm sorry, I don't want to belabor the point, but I'm still confused. So if there are several people working and they have to organize their shifts, and everybody really wants the shift that starts at 11 a.m., but there's only one or maybe two such shifts. So
Yeah.
Again, envy
So
freeness-
I agree that there can be contexts where envy freeness cannot be met, and especially for this one, when these outcomes are continuous, then I think there's some compromises made. So it's envy free up to one good, for example. But still, there are contexts if there is only 3 jobs and there are 100 people, envy freeness will be probably impossible. Yeah.
You could have ex ante envy freeness, where like you all have the same probability of the 11 a.m. shift.
Sure.
No,
But I didn't hear the phrase ex ante in the discussion of envy freeness. Yes.
So, thank you. Yeah. So for the exact concerns, like sometimes situations are unfair, so that people will think the decisions are unfair, whether it's from the algorithm or human, for that kind of context, right? Because there was the imbalance between what's available versus the demand. So when I first studied this particular algorithm, I was more curious on like how this decision automation impact group dynamics. So I kind of did a pilot studies where I allocated a task to people using the algorithm that we'll talk about shortly. And then people were saying, before talking about group dynamic, this allocation is just unfair. So I was talking to people who create this algorithm. People are saying that this algorithm is unfair, and they were, yeah, well, people will never think that any decision is fair. So that's why I kind of wondered.
I mean, there is a different, it's a different model, because you're talking about managerial or governmental decisions. So there are two entities there. There is the one that holds the resources and the one that applies for resources. When you're talking about fair division, it's the same group that plays both roles. I mean, if I want to divide my cake with you, then we're both the suppliers and the consumers. It's not that there are two different entities.
I will argue that depending on the context, there can be two entities. Like, for example, scheduling shift. It's still the management who deploy the algorithm.
Then I don't see how we achieve envy freeness. The envy freeness comes from the fact that I'm also the one who allocates the resources,
Maybe we should,
not only the consumer.
Maybe you should proceed, because when she gives the example of how she used the envy freeness, maybe it'll clarify that the situation will clarify itself. But we need to go on. Yeah.
Okay, but I've been focusing on how people perceive the decisions from these algorithms. So actually, there will be not a lot of discussion about envy freeness here, but I'd love to hear more thoughts on after this talk. Yeah. So so to test these, I guess, precision of decisions, whether it's made by the algorithm versus human, we wanted to use a real-world task for this one. So we brought people to a kitchen lab and told them that they were sharing an apartment and had to divide chores to prepare for a house party. And half of the participants used the fair division algorithm, and the other half discussed among themselves how to allocate the task. So we use a website called Splitit. It's made at CMU. And each participant used the interface shown on this slide to indicate that how much they prefer each task as compared to the baseline task by writing multiplier. So here stating how many times they would do one task to avoid another. An algorithm then assigned the task to each individual to minimize each individual's perceived burden with efficiency. And participants actually had to carry out the chores in the lab. So in retrospective, this was a great time to come to the lab every day because it was squeaky clean and smelled really nice for a few months. We even had people making fresh coffee and lemonade every hour.
Did you ever quit? Did you ever stop the experiment?
No, I never stopped the experiment. Yeah.
More data is needed.
And after they finished the test, each participant filled out the survey and was interviewed individually. So what did people say after carrying out the chores assigned to them, either by algorithm or through discussion? So when algorithm divide a chore, participants thought that decisions were only somewhat fair on average, and 40% of them thought that the outcomes were not fair. On the other hand, when people decided who was working on what through discussion, they thought that decisions were pretty fair. So overall, discussion-based outcomes were generally perceived as fairer than algorithmic decisions. And the interview suggests that the gaps between algorithmic assumptions and human behavior contributed to the perceived unfairness of the algorithmic allocation. So the fair division algorithm implements equity-based fairness using individuals' preferences so that in the best case, each participant gets a test that they like most, and they don't get the test they hated. But participants had a more diverse concepts of fairness. Some prefer equality, everyone getting just the same amount of task, or getting a task randomly. And they also had a varying definitions of utility. Like, for example, some wanted the algorithm to consider additional factors, such as individual skills, or the time that each task takes, so that in the best case scenario, the quality or duration of task is also optimized. And the fair division algorithm also assumed that individuals are rational actors who want to maximize self-benefit. But in reality, some of our participants were willing to compromise to help others. So they value the happiness of the group as well as their own profit. and they wanted to accommodate others' needs. So these people wanted the algorithm to consider these factors or at least support these behavior. So for example, one participant said that he wanted the software to collect the reasons why people wanted certain options so that he could later decide whether to alter his share depending on other people's reasons. So I explained how the gap between the algorithm assumptions and social context created perceived unfairness in assignment. Let's now look at why discussion was effective. So in the interviews, people said that discussion gave autonomy to each group so that they could decide what was fair for them and how the utility was defined. So some groups considered people's preferences and skills, while other groups focused on everyone working for the same duration of time. And in discussion, there was also social transparency. People could understand each other's preferences, and if they didn't like certain tasks, they could voice their concerns and make adjustments to increase overall fairness. So this result shows that the lack of procedural fairness in algorithmic decision might be a reason why their decisions are perceived as unfair. So procedural fairness is the perceived fairness of the decision-making process, and it often plays as an important role as the actual outcome distributions. So it has two main components: the quality of decision-making, or whether the process allows people to understand how the decision was made, and the quality of treatment, or social aspects of groups and the ways people experience interactions. So in our study, discussion had afforded these two qualities, whereas the algorithm decision had not. So it shows the takeaway is computational guarantee alone are not enough, and maybe we should think about procedural fairness around this algorithm.
Can I ask a
So-
question?
Yeah.
So one comparison I'm curious if you experimented with or thought about, here you're comparing sort of a centralized decision made by an algorithm with a very collaborative decision made internally by a group.
Yeah.
But do you know what would happen if we were comparing the algorithm to an opaque decision being made by a group that I know nothing about? So
That's an excellent comment. So we really debated a lot on whether to make it this discussion based or have one authoritative person who is giving them decisions. And as a first experiment, we chose this one because it was not that people were attributing they were using it as a tool. They didn't say that this is an algorithmic boss that's giving me the tool in our context, so we use a discussion. But I love to follow up with a human decision maker giving the work to the people.
I have a follow-up. Suppose you actually have an algorithm making a decision and you have the group making a decision, except that you don't actually report the decision in a way that associates it with who actually makes the decision. Would the perception of fairness be influenced by how you thought it was created? So for example, you could just randomly assign the outcome to the two different procedures and report it differently. And then maybe the whole thing about perception is that you think it was done through decision making, whether or not it was. You see what I'm getting? So suppose the algorithm says, okay, you're going to go to Arizona, and the decision says you're going to go to Nevada. And if you swap the outcomes, but we say that actually the group decided Nevada, but in fact the group actually had decided. Okay, so would the perception of fairness be based not on the actual outcome, but just on the process?
It's a fair point, and I actually wonder about that too. Like the outcomes from the algorithm versus discussion, would the outcome itself vary a lot in the way the allocation decision was made? Just based on the interviews, I had a strong feeling that it was about the transparency and they are seeing what's happening, whereas algorithm, you just get a result and you don't know what's going on. So in our interviews,
Any outcome as long as they think it's transparent.
oh,
Potentially.
If-
It's the perception of transparency and thinking you're engaged that's
that
important.
is true. So there is a huge, illusion of control is a huge field in psychology. And even though you don't have control, if you feel like you have control, you will feel better about it. I think there is an ethical discussion we should have whether, like, how much we should actually leverage illusion of control or think about how to give the actual control to people. Yeah. So we've been reading a lot of papers on procedural justice from like law, psychology, and then we are working on mapping out important factors that we should consider along the process of algorithmic decision. So for example, like there is two kinds of things that we can explain in algorithm. One is a standard, or what algorithm they're using, or what data it is based on. But also there is a different transparency can be applied to decision outcomes. And I will explain later that maybe the transparency of standard versus algorithm may have a slightly different impact on how people perceive the algorithmic decisions. And the other level is whether people have control over the decision-making process. So for example, the algorithm itself, or just the outcomes that they get. For example, you get on some assignment and then you have a chance to appeal or swap it with another. So there will be another person of outcome control. And the third one is general principles, social aspects of this process where the decision makers have a good intention toward the people who are affected by, whether it's consistent, and whether it's related to your comment on control, like illusion of control, or just whether people have actually a chance to just voice their concern, even though they cannot actually change the outcome. So in the next study, we actually tried to look at how can we actually give people over the algorithm control over the algorithm than making these managerial decisions, and how can we actually make this algorithmic decision more transparent. So for the remaining time, I'll probably focus on this second project. So here, I'll first propose a participatory framework that we call We Build AI. And then I'll present a case study in the context of on-demand donation transportation service. So the key idea of our framework is that we build a computational model that represents each individual stakeholders, and to have that model negotiate or vote on its individual behalf. So this works like a group of people making a decision together, like you saw in our discussion-based condition in the first study. But instead of an actual individual in the room, virtual computational models of each individual decision-making process will make group decisions for each algorithmic decisions. So our framework consists of 4 steps, and I'll explain these in more detail in our case study. So our case study was done with a real nonprofit called 412 Food Rescue. It is an organization like Uber for charity. So they take food donation from donors, such as grocery store and retail stores, and allocate them to nonprofit that help underserved food insecure communities. So examples include food pantries, homeless shelters, and public housing communities. And they use an app to coordinate volunteers to pick up and deliver the donation to the nonprofit. And the organization has been quite successful. They have about 800 donor and recipient organizations, and have a pool of thousands of volunteers. And they are expanding their model into 4 other cities, including San Francisco and Philadelphia. So this profit wanted to introduce an algorithmic allocation system for 2 reasons. So one is to offload dispatcher workload. The other one is that to improve equity in their donation distribution. So current donation distribution is quite skewed, 20% recipient organization getting 70% of donations, because allocation decisions are often made for convenience by human decision makers. So in designing this allocation algorithm, we focused on the trade-off between the equity and efficiency. So in other words, so we focus on this because it's a fundamental challenge that we deal with in our capitalist democratic societies. And also it requires a normative approach. So in other words, a human needs to define how to balance these competing factors, because there's no fundamental right balance between the two, and we cannot just determine purely through optimizations. So in this context, this design choice can have different impacts on different stakeholders. For example, let's say this allocation algorithm prioritizes efficiency and gives donation to recipients closest to donors. And it will be convenient for volunteers because they don't have to drive long, but it means that donation distribution will be skewed because donors are often located in a wealthy area, so recipients in wealthy area will get more donations. But on the other hand, if the allocation algorithm prioritizes equity, recipients with greater needs may receive more, but this may increase the distance that volunteers need to drive, as well as the effort for 412 rescue that span in recruiting the volunteers. So we wanted to find a collective solution to this trade-off so that the algorithm doesn't make decisions that disadvantage certain stakeholders in an unacceptable way. And all stakeholders will be more motivated to continue participating in the service if they feel their needs are respected. So to this end, we use a framework to build the algorithm with 4 types of 412 rescue stakeholders. And I'll walk you through each step of our framework application. The first step was to determine what features or input information the algorithm should use based on the feedback from the stakeholders. So for this, we conducted interviews with these stakeholders to understand what factors they thought the allocation algorithm should consider. So for example, poverty rate as a one indicator of client needs, distance between the recipients and donor as a metric of efficiency. And next, we use these features to model people's individual beliefs. So we used 2 methods iteratively. The first method was machine learning based. So we trained the model using participants' answers to pairwise comparison scenario that show 2 recipients who vary along the features from step 1. So you see that we used 7 factors, and then we presented the pairwise comparison scenario so people can choose which recipients should give donations. But we also used other method that was more explicit rule specification. And we went for really high tech and asked people to place weights on a Post-it card so that they can actually tell us like how much weight each factor should have. And we use these 2 methods iteratively intentionally so that people could use a bottom-up pairwise comparisons to get more familiar with the scenarios, but also tell us what they think should happen in a more direct way.
And they're speaking for themselves, right? Each
Yeah.
person is saying what they would like to happen for
Yeah.
themselves.
Yeah.
For other people.
Yeah.
who are
Well,
the
the one clarification.
Volunteers here?
It was of all volunteers, donors, recipient organizations, and the Front to Food Rescue staff members.
Not the recipients?
So we had for our interviews, we had a recipient organization's client, but for this one, we used the recipient organization representative as a representative of the clients. Yeah. And once participants complete the model, we visualize the 2 models that they built through the process and then ask them which model better represent their model. So what was surprising to me is this graph may look complex. I don't know. We first used the factor that show, we used a simpler graph than before, but then that was not enough for people to understand what was going on. So we show like on x-axis, we show the range of the input variable, and then y-axis how much weight it will have. And you see that for this one, the model that they created themselves versus the answers to pairwise comparison looks remarkably similar. For some participants, the model that they created themselves, which is represented orange versus model that they trained, looked really different. So in this kind of context, participants were shown this graphic, and then they were asked to explain the difference and asked them they chose a model that they think they best represent their model. And at the end, the final model had about like 88% accuracy. Overall, machine learning model was more accurate, but there were some instances people wanted to choose a model that they created. I'm not going to cover that in this talk, but I'm happy to talk about it if anyone is interested in it. So once we build this final individual model, we implemented that model for each participant in our system. So in our system, for each incoming donation, each individual model that participant built in the previous step create a ranked list of potential recipients. And these individual lists were aggregated using a Borda voting rule to create the final recommendation list. And then in the final step of the framework, we explain these algorithm recommendations to participants to support the decision maker's operation, but also they know that how their participant was actually used to create the final algorithmic decisions. So we show the overall voting score, how the different recipient organization was ranked by different stakeholder groups, and then we highlighted the factors that made this recipient recommended. And like you see in this video, we implemented this recommendation and decision support system in the web application that this organization uses, so that for any incoming donation, they will see a list of recommendations and where it's located and why that's recommended. So that concluded the algorithmic building process. So what did we learn through this process? So one of our initial hypotheses was that having people involved in this algorithm building process will improve the perceived fairness of the algorithm. It will motivate them to use the service more, etc. And the interview suggests that actually we saw the effect that we were intending to see. So one of my favorite quotes from our participant was that these are everyone's brain power who are deemed to be important in these decisions. So it should be the most fair that you could get. And they also really appreciated that the organization considered all stakeholders' feedback, so it improved their trust in the organization as well as the algorithm. So one uncertainty that we had initially was, yes, we can open up this algorithm building process, but what kind of outcome this open process will lead to? So we ran a simulation using the 5 months historic donation data. And it shows that the donation was more equally distributed compared to how human decision makers have been making decisions. So this is a Gini plot that shows that the blue one is the algorithmic allocation, and the orange one that's really skewed is the how human decision makers have been making decisions. And it also shows that the algorithm gives donation, the blue line, to areas with a higher poverty rate compared to how human decision makers have been making decisions. There was one unexpected finding for me. So it was that the experience of making the individual model, the step 2, in itself had a significant effect on the participant, particularly their awareness of the algorithmic capability and then the organizational inconsistency. So because participants became more aware of how algorithm work by training it and then working on the scoring activities, they became more accepting and less resistant to the idea of using algorithm in the first place. So one surprising moment was when one participant told us that unprompted, he now believes in algorithm wholeheartedly. So he was very skeptical that algorithm could make such a complex decision that involved caring for others. So he was not sure whether algorithm can make such decisions. But after going through the step-by-step process and seeing that the algorithm makes a decision that he would have making, he thought that he now believes the algorithm can make such decisions. Secondly, the experience of making allocation themselves had participants develop more empathetic stand toward the organization. They mentioned that they now realize that the difficulty that the 412 rescue faces, and there might not be one perfect solution for everyone. So this is an important change because it can improve people's tolerance and understanding of the trade-off that are often in governance decisions. Finally, building the individual model also revealed inconsistency in the organizational decision making. So the staff at 412 Rescue told that they have an internal guideline that they rely on to make this donation allocation. And since all staff members act according to the same guideline, they were surprised that their models actually vary in the ways that they weigh poverty, organization size, and clients. So these findings suggest that this elicitation method can be a useful tool for discovering inconsistencies in organizational practices. So to summarize, our framework allows people to collectively build an algorithm for their own context. and it shows that it can lead to algorithms that better reflects their principles that stakeholders value and find fair, and it can improve algorithmic awareness. So for the remaining few minutes, I'll briefly talk about how we are thinking about giving outcome control to the people. And going back to the original setup that I presented earlier, we were kind of thinking about how can we actually improve the perceived fairness in the allocation setting that I discussed in the first study. So we built a web application that explained these division decisions. There we first explain how this fair division algorithm make the fairness decision, weighing different people's utilities. So it gives people a chance to understand the algorithmic standard. And then we explain different people's input utilities and how this results in the final allocations, so in this table format interface. So our study suggests that initially there are two groups, people who thought that their outcomes are really fair because they got the ones that they wanted most, versus people who thought that it was really unfair because they didn't get it. By adding the transparency, it actually decreases the people who thought that their outcome was fair because they thought that because they got the good outcome, they assumed that everyone else got the good outcome. And then seeing the explanation for themselves and for others, they realize, oh, actually, I'm the one who got the good deal, but there are other people who didn't get good deal. So their judgment of fairness decreased. But at the end, we asked them to whether they to adjust the kind of outcome themselves, then that universally increase the perceived fairness of the outcome. But we are aware that not all the cases people can have this direct control over the outcome that they get. So, and then we also found a lot of unexpected findings about transparency. For example, because we made the algorithm really transparent, they suddenly started blaming the input data for the unfair outcome, not the algorithm. Or even sometimes for other participants, they had a weird preferences, so that's the why this is unfair, etc. So the preliminary findings suggest that these reactions of these perceived fairness is a very complex, nuanced phenomena, and there needs to be more studies. So this is 3 takeaways, and thank you.
A couple of questions.
I think that there is a really confusion between two meanings of fairness. Because one is when I'm controlling resources, like I'm a judge, and I have to decide on bail, and there is one notion of fairness here where I have the resources and I have to distribute it. The other notion is that we play both roles. That we are a group of people, we want to divide the apartment between us, who will get which room, and we are both on the side that has the resources and the recipient. And I think that just because we have one word, fairness, for both situations, we tend to consider them together, but I think they're completely separate. I don't think it's the illusion of control, but it's really the responsibility. If I'm also owing the resources, then I make different decisions than when I'm only a recipient. It's not about an illusion of control. It's about two different games that are at question.
So my short answer is I agree with you in this context, especially not the formative food rescue case study, but the lab experiments were focused on situations where decision makers are also affected by their decisions. So I agree that, so our follow-up studies will look at the different contexts where there's a distinct decision maker who may have more power or less power, and then those who are affected by them.